At this point, we should understand the concept of a limit. So we're going to use that limit definition and combine it with what we know about slope to develop the definition of a derivative. So previously from an algebra class, you may have learned a slope definition. And what the slope definition says is that if you're given 2 points, say y1, y2, x1, x2, you can determine the slope between those 2 points by saying the change in y, y2 minus y1 over the change in x, right? So slope is the vertical change over the horizontal change. And we also have formulas that we use for developing equations of lines. So one that I find really helpful is our point slope equation. My point slope equation says that given a point and a slope, that I can find the equation of a line. So if I had a point, x1, y1, I could say that my point slope equation would be y minus that y value from my point is equal to m, the slope, times the quantity, x minus x1. All right, so that's my point slope equation. And that helps me develop my slope intercept equation, y equals mx plus b. And if you don't like using this point slope equation, that's perfectly fine. You can use y equals mx plus b, but I'm going to work through the problems using point slope. So I just wanted to make sure we knew our slope and our point slope equation before we began talking about the derivative as slope, or slope as the derivative. So at this point, we are going to redefine our definition of slope. We're going to think about it the same way. It's still rise over run, change in y output values over change in x input values. But we have this limit part of a definition. So this is the limit definition for slope. The slope of a curve, any curve, just a function of x, at some initial point, x naught or x sub 0, and then your y value when you plug in that x sub 0. So at any point p, the slope can be found by calculating the number. And the number is the limit as h approaches 0 of change in some y values. And normally, we have an x here instead of an h. We say as x approaches 0, but in this case, an h approaches 0. So we've got h in the denominator. So really, this is still our same change in y over change in x. All right, so I'm going to draw a picture to kind of help illustrate that a little bit better. So we may have a curve, right? A curve here with 2 points on it. And if we wanted to find the slope of a line, right, if we had those 2 x points, we would simply use our slope formula. But we may want to find the slope of a curve or the slope at some specific point, right? So if I had this point and I wanted to know, well, what's the slope right there? It's going to be similar to that gray line I've drawn, but it would look a little bit different. And how do we calculate that? So, say these were 2 x values. Say we had an initial x value, x sub 0, which is the x value at the point where we want to determine the slope. And maybe we have another x value off to the right, and we'll call that x sub 0 plus some distance h. So h is this added horizontal distance. It's the distance between my 2 x values. So what would those output, the y values, be, right? Considering this is a curve, we're dealing with y being a function of x. So my output value would be f of x sub 0. And then my second output value, I would have f of x sub 0 plus h, because that's my input that I'm plugging in there. So if we set this up and we tried to think about our slope equation, which is change in y over change in x, I would take my two y values and subtract them. F of x sub 0 plus h minus f of x sub 0. All of that would need to be divided by my two x values, which would be x sub 0 plus h minus x sub 0. So I'm literally just redefining the way I talk about my points. Instead of using x1, y1, x2, y2, I'm using x sub 0 and then some y, which is off of that x sub 0, and x sub 0 plus h as an input, and then again some y value. And if we look at simplifying what we have in the denominator here, x sub 0 minus x sub 0, those are going to cancel each other out. So what we have right here is the same as what's in this given definition of the slope of a curve. All right? So we've really just redefined the way we're talking about slope. And our goal here is we don't want to find the slope between 2 points, because the slope between 2 points represents what we call the secant line. We want the slope at specifically just this 1 point right here at x sub 0. So we want that slope right there, which is a little bit different. So in order for me to do this, what we think about doing is letting this x sub 0 plus h, having it become really, 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 really close to my original x plus 0, to the point where I'm essentially adding 0h, right? So we're looking at the limit as h approaches 0. So let me kind of illustrate this a little bit differently. I'm going to erase what I have here. So thinking about that same drawing with just a little bit less information on it, right? Again, we want to determine the slope specifically at this point, x sub 0, right? Which would look roughly like that red line I've drawn there. What we're not interested in is the secant slope. But admittedly, if I make that x sub 0 plus h point, if I let that get closer and closer to x sub 0, to the point where the limit of h, remember h is the distance, that horizontal distance between these 2 points, that represents my h, to the point where that h is almost 0. So rather to say, if I picked a point right here, right beside it, that dark point and my green point I just made are very, very close together, and the gap between them is small, much smaller than it was initially. Would you agree that if I drew a secant line through those 2 points, that would be pretty close to the tangent line at x sub 0? So the idea here is if I make that gap infinitely small to the point where those 2 points are basically identical, the same point, then I'm going to find the slope of the tangent line. The reason we have to introduce the limit as h approaches 0 is because h in the denominator, that h value is not allowed to equal 0. I can't let the denominator equal 0, or the function the limit that I'm finding here would be undefined. So it can't equal 0. We just want to say that it's so infinitely small that it's basically equal to 0. All right, so think about that. Think about the definition. I want to make sure you understand the definition before we employ it. Okay, so this is our definition for the slope of a curve. And essentially, you are going to need to know this formula and how to use it. So in the next video, we'll talk about finding the slope of a curve at a point.